This assessment asks us to draw the three most stable Newman projections looking down the AB bond of 2,2,4-trimethylpentane. Let's get started. We're going to identify carbon A as being the front carbon. There. At carbon A, we have a methyl group, which is good. We have a methyl group, which is here, and a hydrogen. We'll draw on our circle. Behind that circle is carbon B. If you look at what's attached at carbon B has two hydrogens and a tert-butyl group. So we can draw a hydrogen, and a tert-butyl group. That will be our first Newman projection. To generate the next two, let's keep what's in the front the same and rotate what's in the back. And so by keeping the front the same, we can just redraw it as is drawn here. Draw our circle. We'll move our tert-butyl group 120 degrees in the clockwise direction. So the tert-butyl group will go here, hydrogen here, and hydrogen here. Still, this being carbon A. The next structure we can draw, we'll keep the front the same again. We'll draw this down here. Draw our circle. This is our hydrogen. This is carbon A. Our tert-butyl group that now was in the upper left will now be in the upper right. Hydrogen and hydrogen. These are the three most stable Newman projections because they are all staggered conformations. How do we pick which one is most stable? Well, here we have a tert-butyl group that is gauche, or 60-degree dihedral angle to a methyl. So we have one gauche interaction here. This Newman projection has a gauche interaction here and a gauche interaction here. So we have a total of two gauche in this Newman projection. Gauche interactions being unstable. This Newman projection here has only one gauche interaction. And so Newman projection A and C, we'll call this one B, Newman projection A and C represent the most stable conformation of this molecule looking down the AB bond.